Hello my dear student, very good morning to all of you. I will explain addition reaction of halogen acid to unsymmetrical alkene. That is, in this chapter I will try to explain Markovnikov and anti-Markovnikov reaction. The first question arises, what is unsymmetrical alkene? When around the double bond, number of carbon atom attached to each of the two carbon is different, then this is known as unsymmetrical alkene. Consider the example of propene 1. Here carbon-carbon double bond in between terminal atom, and on the right hand side of carbon number 1 there is no alkyl group, and on the other hand of the carbon atom there is an alkyl group. So this is the unsymmetrical alkene. Let us explain what is Markovnikov and anti-Markovnikov reaction and how does this happen. During the addition of an unsymmetrical alkene, the hydrogen prefers the atom with more hydrogen. The halide joins the other carbon. Let me clarify again. During the addition to an unsymmetrical alkene, the hydrogen atom prefers the carbon with more hydrogen. The halide joins the other reaction. And number 2, this rule ensures that the reaction proceed through the carbocation. Let me explain in detail. This is the propene CH3CH double bond CH2, and here is the halogen acid HBr. Suppose there is a heterolytic cleavage. Heterolytic cleavage means both the shared pair of electron in between hydrogen and bromide moves towards more electronegative atom, that is bromine. This bromine will acquire negative charge and hydrogen will acquire positive charge. The species having the positive charge are known as electrophiles because they are positively charged. That's why we denote E superscript plus. And these are the electron loving species. What are the electrophiles? Electrophiles are the electron loving. It means they are themselves positively charged. And on the other hand, nucleophile, this bromide ion is the nucleophile, nucleus loving. This means nucleophile will have a negative charge. Then what would happen if the propene 1 reacts with the HBr and there is a heterolytic cleavage? Hydrogen atom will attach either to this carbon or to this carbon. These two routes have been indicated by different colors. The first route is indicated by green color and the second route is indicated by the red color. In the first route, this C1 is being attacked by hydrogen, and in the second route, C2 is being attacked by hydrogen atom. Then there is a possibility of formation of two type product. Number 1, product 1 and product 2. As you are seeing in the product 1, if hydrogen attaches to this carbon, then this will acquire positive charge and this will become carbocation, and which is a primary carbocation. This is the primary carbocation, and this is the less stable as compared to the secondary carbocation, and which is less stable than the tertiary carbocation. Tertiary is the most stable, followed by the secondary, and primary is the least stable. And what would happen if the second route is followed? Then there is a formation of secondary. Secondary means carbon is attached by two other carbons. Here carbon is attached by carbon number 1 here and carbon number 3 here. Around this carbon there are two carbon atoms. That's why this is known as secondary carbocation. And here this carbon is primary because this is attached by only one carbon. There is no any carbon on this side or this side or this side. This carbon is only attached with one carbon. That's why this is primary carbocation, and here carbon is attacked by two other carbons from two different sides. This is secondary. That's why this secondary carbocation is more stable, and this product too would be preferred. That is hydrogen will attach, that is hydrogen will attach to this. Hydrogen prefers carbon with more hydrogen here. Here there are two carbon and this is third addition of third carbon. Or in other words, you can say that halide ion will prefer the carbon having least hydrogen or more alkyl substituted. Here least hydrogen and more alkyl substituted. Here is the alkyl group. That's why this bromine will come to this point. This is the Markovnikov rule. Let us come to the second anti-Markovnikov. Halogen attack the carbon atom having the more hydrogen atom. Here is the again the same substrate, propene 1, and this is attacked by HBr, the same attacking reagent, but here the reaction is going under the presence of peroxide. Under the presence of peroxide. In the former discussion there was intermediate and that intermediate was carbocation, and in this case free radical mechanism takes place. Two different products are possible. This is number 1 and this is the number 2. Here this is the primary free radical and this is the secondary free radical. As you know, the stability of free radical is opposite to that of carbocation. In the case of carbocation, tertiary is the most stable, followed by the secondary and followed by the primary. But in the case of free radical, primary free radicals are more stable, followed by the secondary and followed by the primary. Here this will be the primary free radical because this carbon is attached to only one carbon, and here in this carbon is attached to two other carbons. That's why this product is not least favorable. This product is least preferable and this product is more preferable. That's why I have not drawn the arrow. I have simply drawn this red arrow. It means this route is possible only. Let us come and have some more discussion. How does the Markovnikov rule mechanism? The mechanism behind the Markovnikov addition is have two major steps. Number 1, protonation. Alkene reacts with the hydrogen atom from the halogen acid, forming a carbocation intermediate. The hydrogen bonds to the carbon with more hydrogen, giving the more stable carbocation, as you have seen the secondary. And second, the nucleophilic attack. Halide attaches to the carbon atom, producing final alkyl halide. This is the example. Let us come to some more discussion. Markovnikov versus anti-Markovnikov rule. In certain cases such as SBr and organic peroxide, addition reaction follows the anti-Markovnikov rules. As I have already told that anti-Markovnikov addition takes place under the presence of peroxide. If the peroxide is not present, no anti-Markovnikov rule will take place. Here the halogen attaches the carbon with more hydrogen opposite to the Markovnikov pattern. This is due to the difference between the mechanism. Markovnikov rule proceed via carbocation intermediate, while anti-Markovnikov reaction proceed via free radicals, and the stability of carbocation is contrary to that of free radical. The carbocation, the tertiary, is the most